For today, we are going to discuss addition and subtraction of radical expressions. When adding or subtracting radical expressions, you need to check first if they are like. When we say like radicals, these radicals have same root number, which is called the index, and same radicand, which is the expression under the radical sign. This time, let's try to identify whether the following radicals are like or unlike. 2 square root of 3 and negative 5 square root of 3. Let's have first 2 square root of 3. For our index, which is on this part, is invisible. Therefore, it is equal to 2. For our radicand, which is the expression written under the radical sign, is 3. Now let's proceed to negative 5 square root of 3. For our index, which is located on this part, it's again invisible. Therefore, it is equal to 2. For our radicand, the expression written under the radical sign, it is 3. So we now compare. The indices are the same, the radicands are the same, therefore, the given example is similar or like radicals. For our next item, we have square root of 2 and square root of 6. For square root of 2, the index is equal to 2. The radicand is equal to 2. For square root of 6, the index is 2. The radicand is 6. The indices are the same, but the radicands are different. Therefore, the given radicals are unlike or the similar radicals. Next, we have 5x square root of 2y and 3y square root of 2y. For our first given radical expression, our index is equal to 2. For our radicand, it is equal to 2y. We proceed to our next radical expression. Our index is equal to 2. Our radicand is equal to 2y. Our indices are the same, our radicands are the same, therefore the given radical expressions are like or similar radicals. For our last item, we have cube root of 7x and square root of 7x. We take first cube root of 7x. The index is equal to 3. The radicand is equal to 7x. We proceed to the next given radical expression, square root of 7x. Our index is equal to 2. The radicand is equal to 7x. The indices are different, and the radicands are the same. Therefore, the given radical expressions are unlike or dissimilar radicals. To add or subtract radicals, the indices and the radicands must be exactly the same. If the indices and radicands are the same, then add or subtract the terms before each like radicals. If the indices or radicands are not the same, then you cannot add or subtract the terms before the radicals. Let's have first addition and subtraction of similar radicals. For our first example, we simplify 8 square root of x plus 2 square root of x. The index of our first term is 2. And the index of our second term is also 2. Notice that their radicands are the same. So the given terms are similar. We now combine positive 8 and positive 2. The answer is positive 10. Then we copy square root of x. So the simplified form of 8 square root of x plus 2 square root of x is equal to 10 square root of x. For our next example, we simplify 4 square root of 5 minus 3 square root of 5. Indices are the same. Radicands are the same. So we combine 4 and negative 3. And the answer is positive 1. Then we copy square root of 5. We simply write it as square root of 5. 1 will become invisible. For our third example, we simplify 3 fourth root of 2 minus 6 fourth root of 2. Our indices are the same. Our radicands are the same. We combine 3 and negative 6. And the answer is negative 3. Then we copy fourth root of 2. So the simplified form of 3 fourth root of 2 minus 6 fourth root of 2 is negative 3 fourth root of 2. The similar radicals cannot be added or subtracted unless they are transformed or simplified into similar radicals. Take note, some radicals are not similar, but may become similar when simplified. When simplified, but they are still unlike, then just copy the simplified terms. Now let's try to add and subtract the similar radicals. For our first example, we simplify square root of 8 plus square root of 50. Square root of 8 can be simplified. The perfect square factor of 8 is 4. Square root of 8 will be written as square root of 4 times square root of 2. Square root of 50 can also be simplified. The perfect square factor of 50 is 25. Square root of 50 will be written as square root of 25 times square root of 2. Square root of 8 plus square root of 50 will now be written as the square root of 4 times square root of 2 plus the square root of 25 times square root of 2. We get the square root of 4 and the answer is 2. Then copy square root of 2. Plus, we get the square root of 25, the answer is 5. And copy square root of 2. Notice that our indices are the same and our radicands are the same. Therefore, we can now combine positive 2 and positive 5. The answer is positive 7. Then copy square root of 2. So the simplified form of square root of 8 plus square root of 50 is equal to 7 square root of 2. For our second example, we simplify 3 square root of 12 minus 2 square root of 48. Square root of 12 can be simplified. And the perfect square factor of 12 is 4. So 3 square root of 12 will now be written as 3 square root of 4 times square root of 3. Square root of 48 can also be simplified. Perfect square factor of 48 is 16. 2 square root of 48 will be written as 2 square root of 16 times square root of 3. 3 square root of 12 minus 2 square root of 48 will now be written as 3 square root of 4 times square root of 3 minus 2 square root of 16 times square root of 3. We now simplify 3 square root of 4. It will now be written as 3 times 2. Copy square root of 3 minus, we simplify 2 square root of 16. It will become 2 times 4. Then copy square root of 3. 3 times 2 is equal to 6. Then don't forget to copy square root of 3. Minus, we get the product of 2 and 4, the answer is 8. Then copy square root of 3. Notice that our radicals are now the same. So we can already combine positive 6 and negative 8. The answer is negative 2. Then copy square root of 3. So the simplified form of 3 square root of 12 minus 2 square root of 48 is equal to negative 2 square root of 3. For our third example, we are going to simplify square root of 3xy plus 6x squared square root of 27x cubed y. Square root of 3xy is already in its simplified form. Now let's proceed to our second term, which is 6x squared square root of 27x cubed y. We copy 6x squared, then observe your radicand. 27 has a perfect square factor, which is 9, and to be multiplied by 3. We proceed to x cubed. Its factors are x squared and x. And for y, we simply copy it. So it will now be written as the square root of 9x squared times 3xy. We copy 6x squared times the square root of 9x squared, which is equal to 3x. Then copy square root of 3xy. We now get the product of 6x squared and 3x, and it is equal to 18x cubed. Then copy square root of 3xy. Square root of 3xy plus 6x squared is square root of 27x cubed y will now be written as square root of 3xy plus 18x cubed is square root of 3xy. Notice that our radicals are now similar. So we are now ready to combine the terms before the radicals. In our first term, our coefficient is invisible, and that is 1. Since we cannot combine 1, which is a constant term, and 18x cubed, which is a cubic term, just simply place them in the grouping symbol, then copy square root of 3xy. So the simplified form now of square root of 3xy plus 6x squared square root of 27x cubed y is equal to the group of the sum of 1 and 18x cubed times the square root of 3xy.